before we do a final check of the system, we can definitely see the differences of the meshes. So if I open the simplified mesh here, and I will see there's some differences between the previous one, so I can turn it on the previous, but it's being overlapped, so I need to move it a bit and give some comparison. So I will give a transfer operation of the previous, so I will move up a bit on 0.1, let's see, and I should see the difference. So this is the previous, so solid color, or I should say the 3. So that is for the previous, the old mesh. If I see the mesh as well, the old mesh, we have definitely see the 3 regions of air, solid, and water. So the solid is aluminum. But if we look into here, so that is most of the recent one, and I also display the meshes. So there's no any solid existed, right? So that means we have eliminated the solid mesh, but only include the thermal conductivity between the interfaces. Okay, that's good to us. And let's do a check of the control dict. So we go to the system and we edit the control dict. So that's block mesh. I need to see the control dict, and it looks good. I still have the 500 iterations with a right interval of 50. So that will give me 10 results files and start from 0. So the latest file is 0. We have defined all the boundary conditions. So now I just need to run the CHT multi-region simple foam, and it should give me the running correctly. So because it's a 2D mesh and the process should be very fast, I can see or monitor results here. It's been 400 now. It should give me the 500 exactly. So I will have the refreshed. I will refresh the results, and that can give me to compare the results. I'll make this a little bit close. So I will just apply 0.05 and say apply it. Yeah, so it becomes closer for the 2, and let's see the difference results. So that is temperature for this. I need to hide them, and that is for the temperature for the surface. And you can definitely say they are very similar to each other, and I can't see big differences of the results, right? So the temperature distribution is very similar. So from the paraView, after loading tool, and we can see the temperature distribution is quite similar, and I can't figure out the difference by visually, and we can definitely see the difference by using some extra features, which means that may help us to figure out the difference. So I will apply here again, and so that is temperature for the bottom one. So I want to plot a line from here to here and from here to here, and then compare the temperature distribution for both. So I want to use the filter, which is plot over line, and remember I want a line from along the x-axis, and the y will be based on the 0.014 and 0.01. That's nearly the center of the air region. and this is the line I defined, and I apply this. I will say the temperature distribution only, and that is for this simplified geometry. But also I want to calculate or plot line over this as well. So I will apply another plot over line for the old. And of course, because we have a solid region here which is 0.002 meters, so 2 millimeter thickness, so I need to define a little bit higher, so that will be 0.016 for this, and it should give me that line. Hopefully I plot it, and then I will only show the temperature again for this one. You will see the temperature distribution for both are quite similar. I can check the difference. So when we compare these two lines, we can use the differences line. So for the simplified one, I want to use a dash line. So there's a line style here. I use dash line. I would see the difference, right? The solid line is for the previous one, so including the solid region, and the dash line is the interfaces only between the fluid and solid, without building the solid zone explicitly. So we would say most of the temperature is similar, but when it approaches the exit, there are some differences, which means there's more like temperature decrease for this fluid region, for this air region, that the solid region is simplified, which means that the heat transfer is more effective rather than the previous one. Or the previous one have the solid region which more precisely capture the temperature decrease a little bit higher, so it's only have like that's 378. This is 376 or 77, so only like 1 to 2 degree difference for the both settings. So that introduced a very simplified way for us if you want to use block mesh to build very simple regions and to avoid the establishment of the solid, but you can definitely define it by using the interfaces with the solid included in the thickness and the thermal conductivity. So that is a simplified version for the previous one, and hope you like it.